Okay, hello everybody. Happy Friday. As promised, I've got some video notes for you guys. So first, just to take a look at all of this is in your OneNote, is in Content Library, so you'll need to go out and get it instead of me sending it to you. But here's the agenda if you guys haven't gone over it yet. So first, hopefully you guys have already checked your homework. I listed the answer key out here. You already had the answers provided, but this is the work shown. So in case you had questions about how to factor it or how to break those radicals down. If you had any questions about your homework, hopefully you could ask a classmate, or you could go ahead and ask them now if you couldn't figure out one of them. Our notes today are going to be solving by taking the square root, so another method of solving equations, in addition to the factoring ones that you just checked. And then the rest of the agenda is, again, after we get to the notes, there's a worksheet here for you guys to practice, which is actually practicing what you did for homework, solving by factoring. Okay, so this is additional practice of that. And then your homework is solving by square roots, which is new material we're going to learn today. Okay, so let's jump into the notes. So just a quick review, when we talk about simplifying a radical, we want to rewrite the radical as the product of a perfect square. So these are the first couple perfect squares that we know of, and we continued. We had more of a complete list last class. But when we want to simplify, like radical 28, we want to look at this list and find out the biggest perfect square that is a factor of 28, and we can see that would be 4. So we rewrite this as the product of 4 and 7. Again, it's best practice to always write the perfect square first, because then when you simplify it, radical 4 is 2. You can't do anything with radical 7. So we simplify radical 28 to 2 radical 7. Okay? So this is a method of simplifying radicals that we're going to use in this new method of solving. So go big screen here. So solving quadratic functions by taking a square root is actually a shortcut, okay? It's a shortcut method that is only used in a specific instance of equations, okay? You only want to use this method if the equation does not have a middle term, that bx term. If you recall, the standard form of quadratic looks like this, right? We have an x squared term, ax squared plus bx plus c, some constant. The method we're going to look today at, shortcut method, is really you can only use it if you do not have this middle term, that x to the first term. You want to use this method when you only have x squared term and a constant, okay, a number, no variable. For instance, x squared equals 16, only has an x squared, only has a number. You can use this method. 5x squared minus 25 only has an x squared, only has a number. You can use it. So when you have this type of equation, the steps are, first you want to get the x squared term all by itself. So you're not setting it equal to 0 anymore. You're trying to solve for x squared. When you get that x squared term all by itself, you want to take the square root of both sides, okay? Now, because we know how to simplify radicals now, we know that they do not have to be perfect squares. They could be perfect squares, but they don't have to be. And when you're solving for a square root, I want to bring up the fact that you actually, when you're solving an equation, like let's say I had x squared equals 9, and I take the square root of both sides. Well, the square root of x squared is x, and the square root of 9 is 3. But if I'm looking for values of x that would, where x squared would be a positive 9, I actually can take the positive and the negative 3 to solve my equation, right? So when you're taking the square root in an equation, solving for x, your answer is actually both the positive of the square root and the negative, okay? So just keep that in mind. So that is going to give us our 2 roots. So that is very important in this, when you're solving this way, is to, when you apply the square root, get both the positive and the negative. And then always, always, always simplify the radical like we did up here. Okay, so let's try some of these. So we look at this one, and again, first of all, can we use our method? And yes, we can. We have an x squared term and then just a number term. We don't have that bx term. So so we can use our method. So we need to get the x squared by itself. So we're going to add 120 to both sides. So we get the 5x squared on one side and the 20 on the other. We're going to divide by 5, again, trying to get that x squared by itself. And we get x squared equals 24. And now, so we've got x squared equals to 24, but we want just x. So we're going to take the square root of both sides, and we get x equals plus or minus radical 24. However, now we look at radical 24, and is that the in simplified form? No, it's not. Simplify that radical to be radical 4 and radical 6, which simplifies to 2 radical 6. So our final answer is x equals plus or minus 2 radical 6. Okay, so there again, just to kind of go over this one more time, I may have done that a little bit fast. We get the x squared by itself. So we've got x squared equals 24. We need just x. So we take the square root of both sides, which gives us just x to the first. And x to the first equals positive or negative radical 24. Always look to your radical and see if you can simplify it. In this case, we can. So we get plus or minus 2 radical 6. Okay, let's try another one. Look at number 2. Again, we have an x squared term and a number term. So yes, we can do it. We want to get the x squared by itself. So we're going to divide by 3. We get x squared equals 9. We want just x instead of x squared. We take the square root. We get x plus or minus 3. Now, some of you may be saying, whoa, Mrs. Kurtz, we did very similar to this last class where we used difference of squares factoring. And yes, you absolutely are right. We could use that on this one. In other words, I think we did this exact problem last class. And what we did was we set it equal to 0. Excuse me. We took out a GCF. We factored the inside. We recognized it was difference of squares. And we solved each factor. Setting them equal to 0. Look what we did. We got 3 and positive 3, which is exactly what we got here. So on these, if you are a big perfect square fan, or I'm sorry, difference of squares, and you recognize it right away, then perfectly fine to do that method. Okay. This method again is just a little shortcut and kind of get you there quicker. For tonight's homework, I want you to always use this method just because we're practicing this method. But on a test or anywhere else in other classes, that you need this to solve, difference of squares or factoring will get you the same answer. Okay. All right. Let's continue. Again, we look at this method, this equation, and this has a couple extra terms, but we still notice that we only have an x squared term and numbers. So once we combine everything, we could definitely use our method. So let's work to get x squared by itself. So we subtract 3, and we get 15x squared is equal to 30. We divide by 15, we get x squared is equal to 2. We need what x is equal to, so we take the square root of both sides, and we get x is equal to plus or minus radical 2. And again, we cannot simplify that any further, so we're good. All right, take a look at the next one. Again, x squared in just numbers. So once I combine them, we're in business. I add 23 to both sides. I get 4x squared equals to 48. I need the x squared by itself, so I divide by 4. I get x squared equals 12. I need x by itself. Take the square root of both sides. x equals plus or minus radical 12. Bingo. However, I look at my radical. I think, could I take anything? Could I simplify that? Yes, I can. Here, radical 12 is radical 4 times radical 3, which is 2 radical 3. So my final answer is x equals plus or minus 2 radical 3. Okay. A couple more. Oops, we can even do fractions. Now, for this lesson, we're only gonna do real simple fractions, even on your worksheet. So carefully look at your worksheet or your homework for fractions too, and let me show you if this process will work. We want to get x squared by itself, so we're going to add our fraction to the other side. We get x squared equals 1/4. Do not make this a decimal. Do not put it in your calculator, okay? When you get a fraction, especially for today and tonight's homework, we're going to have x squared equal to a fraction. We're going to take the square root of every piece. So we're going to take the square root of x squared, the square root of the numerator, and the square root of the denominator. I get x equals plus or minus the square root of 1 is a 1. People tend to not think about that, but 1 times 1 is 1. Square root of 4 is 2. So boom, we're finished. X equals plus or minus 1/2. You will get some fractions on your homework, but for now, I won't promise this all semester, but for now, when you get that fraction, they should be perfect squares. So you can take the square root of the numerator and denominator. Okay, as in this next one. So let's look at this one again. Just a square root and numbers, so we can use our shortcut. We're going to add 30 to both sides. We get 25x squared equals 36. We're going to divide by 25. And look at this, we're getting kind of an ugly fraction. It won't reduce. But if you notice, they're both perfect squares. So actually, this is going to work out great. We take the square root of everything. And we get the square root of x is x equals plus or minus, always plus or minus when you're taking square root in an equation. Square root of 36 is 6. Square root of 25 is 5. So boom, we're finished. Okay. So again, pretty straightforward method. Again, you can only use it when you only have that x squared term and a constant or a number. Okay. And then get that x squared by itself, take the square root. Okay, so that's it for the new material. I want you guys to spend the rest of the time on really either one, and you can tell the sub either one too, but there's plenty of work for you guys to do. But you can either do this worksheet where you're practicing solving by factoring. Everything's already set equal to 0 for you, but you need to factor and solve. And then a way to check this, I did the first one for you. So we factored it, we solved it, and then all the answers are over here. So if you don't find your answer, then you've done it wrong. But they are over here using set notation. So in this case, I found -2 and -5, so I know that that's the right answer. So you can continue on to do these, and you can check your answer. Every answer will only be used once, so you can cross it off once you're finished, once you find it. Okay. Your homework is just solving by taking square roots. So all of these, you can use the new method for, again, isolate the square root and then solve for x. I'm sorry, isolate x squared and then take the square root. So anyway, I hope you guys were able to follow this pretty clearly. And you've got some work to do. So get to work, and I will see you guys next week. Have a great weekend.